I think we all remember Operation Sindoor last year, and today we have a stellar panel with us who are part of the ecosystem. So I'll kindly request each one of you to introduce yourself in 20 seconds.
Yeah, thank you so much for having me. I'm Arjun Rao, partner at Speciale Invest. We're an early stage venture capital firm investing in deep science and tech over the last 9+ years. Invested in more than 40 companies, primarily at the pre-seed and the seed stage. Check size between $500,000 to about $1.5 million. Currently deploying from Fund 3, which is a $70 million fund. Space is an area of very, very strong interest. Over the last 3 funds, we've invested in 7 companies in space tech, and possibly that's why I'm on the panel. Thank you.
Hi everyone, Yashas here. I'm co-founder at Bellatrix Aerospace. We are one of India's early players in the space tech ecosystem, and we went on to solve one of the fundamental problems, which was with regard to components, subsystems, and the basic building blocks that goes behind most of the space missions. And one of the most critical part that we wanted to take up first was propulsion, because India as a country is kind of not yet up to the global mark when it comes to propulsion as a technology. So we wanted to crack that. We came up with green propulsion and a new concept called electric propulsion. And then eventually we have now cracked that, entering the global market, competing with the global leaders here. And then while we are doing it, we are getting into various other satellite subsystems and a new class of satellites called very low Earth orbit satellites. So that's basically in a nutshell.
Wonderful. Hi, my name is Abhishek. I've been in the space tech industry for the last 12, 13 years now. I was, along with Bellatrix, I've had the privilege of being part of the early growth of this industry. I've been with companies like Dhruva Space, Satsure. We even worked very closely with Bellatrix over the years. So I currently am an advisor to the government of Karnataka in setting up the space tech COE, essentially to promote the space tech ecosystem in Karnataka. So yeah, that's about me. Thank you.
Thank you. So it's a common question, open to all. From the time you have been in the industry, how have you seen the ecosystem transition in these many years? So we'll start with you.
Well, when I started, there was little to no private space sector activities. There were a lot of suppliers to ISRO, but they were not independent space companies. They were all structured as traditional subsystem suppliers to the Indian space program. From the mid 2010s, 2011s, the business itself, the business models have transformed, and many private space sector activities have emerged. Back in the day, there were 1 or 2 companies doing this. Today, there are over 300. And this is because of availability of capital, general, government support in through various programs for entrepreneurship. And today, it's very easy to do space entrepreneurship. We have InSpace, which is a single window authorization and private sector facilitation agency. And ISRO itself has many programs which allows for collaboration with them. In fact, I will let Yashas talk about their experiences in starting up, because when they started, there was really no ecosystem. There was just they were one of the few people who were trying to solve this problem. So, yeah.
Yeah, I think as Abhishek mentioned, I think we are talking about 2 very different eras, 2 very different ecosystems here when it comes to how space industry was probably 10 years back versus what it is today. Because 2015, hardly there was Dhruva Space where I first met Abhishek, and then Bellatrix and Team Indus. There were practically like 3 space companies in the country. And today we have more than 300. So I think the era is very, very different. And the main problem back then was regarding regulation and policy uncertainty. If I probably was trying to launch a rocket or trying to put up my own satellite, there was a very high chance I might probably be in jail rather than setting up the satellite or the rocket, right? because we were not at all sure what the government would think of us, whether when we are building a commercial company. One of the most common questions that investors would pose at us is, can you actually sell these out of the country? Right? That was one thing. And if you are not, then if you are selling it only to the government, would ISRO want to really buy from you? Because ISRO is already a leader in terms of tech and they have everything. Then where is the market? Why would you want to take VC money to build a business which finally would not have a market, would not have any licensing? But today, I think with the COVID package which was announced in March 2020, there was also some 20,000 crores which was announced towards revolution in the space sector to create new high-tech employment. So that actually kind of has taken off, and then InSpace was created. InSpace is a governing agency. If you look at US, there is FCC, and in Europe there are a bunch of other agencies which look at it. India had none. Now we have InSpace, which is like a single window clearance trying to enable space companies in all forms, and which after the InSpace has been created, we are now getting better access to ISRO's facilities. Earlier, since Bellatrix was one of the early adapter, we had to set up our own facilities for everything. We were not even sure if we could use ISRO's facilities, and when we tried again, there was initial denials. But today, I think all new space companies can directly go through InSpace, work with ISRO, use ISRO's facilities for their activities. And the policy actually promotes us to export the parts outside the country, which means if I have a ready product and it's really good, the government is going to do its best to help sell it, help get all the clearances. So that way, I think it is very promotive environment as of now. So I think it's one of the golden time or the best time to have the space tech company. But the only issue now, probably the founders may be facing is, more than founders, I think investors would be facing is to identify the right company, right? So you have probably 300 companies, of which probably 150 of them are doing the same thing, and at least 2 to 3 companies are doing the same business model. And out of that, identifying the talkers versus the doers becomes the bigger challenge for investors right now. So I'll just leave it there for Arjun to.
That was my question. I was supposed to ask him. But
Preempted.
I will still ask you that question.
He's always early in everything. No, I think both have articulated this very well, right? We're at a drastically different time from when they started, and even when we made our first space investment, which was now 8 years ago, right? And that time, of course, Bellatrix was there, but possibly, I don't think there were still 10 companies at that point in time, right? Maybe 5, maybe 7, there or thereabouts. And of course, only doing 2 or 3 specific things. But I think basically we've seen explosion on all fronts. What do you need from an ingredients perspective? You need talent, you need capital, you need the market is there, is sort of been obvious. It's possibly accelerated in terms of understanding of the market. Market is there, and then you need policy, right? Honestly, policy is played catch up, right? It's come the last in some sense. We can debate whether we need more capital. We definitely do, but capital at least started coming in. But I think the important thing, talent and capital, really has flushed into the opportunity from India, for India, and for the world. And that is phenomenal, right? We always, in all reality, we should have realized this earlier because we had the ISRO advantage, right? Which is many decadal advantage of some unique know-how that we have as a country. But better late than never. And now, given the technological advances and how the space economy itself is evolving, is just a golden period, as he said. So it's very, very exciting. So I think 2 things have changed: capital and talent. That has really come in quickly.
So what are the filters that you use while identifying like transformative startups in the space tech? Yeah.
Yeah, I'll bucket it into 2 parts. And given the stage that we come in, which is very early, usually, we're always looking for that tech differentiation, right? And when we're looking for the tech differentiation, that unique technical insight is sort of the first question. What is that unique technical insight that this founder or this founding team has to build something new to solve one of the existing problems or upcoming problem? And usually it doesn't come out of thin air. It comes out of a few years of spending in that technical domain, right? So that technical depth and insight from there of what they are solving is the number 1. But equally important, or very close second, if you will, is having a good appreciation for what the space economy is all about, which is basically your market, and slicing it down and say, how is this going to grow? How is this going to, this product that you're building or component that you're building, where is this demand acceleration going to come from? Because remember, this is not a mature industry in the sense that many other industries on earth are, right? The demand is largely future, right? We are just scratching the surface on reaching space, reaching there more frequently, more efficiently, and then doing things there. So a lot of it is in the future. So it's not like the demand is fairly sorted. So there's a lot of extrapolation, a lot of dotted line, predictions out there. So somebody who's really studied the market and understands the nuts and bolts and is able to overlay that with the technical insight so that you can tell the 10-year story of why this is going to be so big, right? That's a rare combination, right? There are people here on the panel who do that, but it's not easy to come along. Those are things that we're looking for.
So adding to that, you are the money man. What's the greenest flag and what's your absolute deal breaker? One each.
Yeah, I think the very strong signal is if you have sent something to space, right? Very few people have done that. So that default puts you in rarefied territory, if you will, right? And that journey and that experience is of immense value because you'll make lesser mistakes. You have experience, you have richness of that. Red flags, honestly, just too many, right? People are rushing it into it with less depth, right? Thinking, doing something, let's say manufacturing or building a component or building a system or a subsystem or a full product, is same as building something on ground and, extrapolating that to it'll work in space or you'll figure out it's an integration problem, right? So I know it's a little hand wavy, but the lack of depth, let's just say the lack of depth is a red flag.
Thank you. So what breakthrough in green propulsion are you working on?
Well, I think when you talk about satellites and rockets, you can imagine huge fuel tanks. Yeah. When you're talking about satellites or rockets, you can imagine huge fuel tanks with a lot of fuel going with it. And most of the time, if you're looking at the kind of fuel that we use, it's a pretty toxic, carcinogenic fuel. When I say carcinogenic, it definitely means that the person's operating and working in the factories producing these kinds of fuel would end up getting lung cancers over a period of time of exposure of these kinds of fuels. People kind of figured that out only recently, that this is the culprit behind such cancers. And after that, globally, the major space agencies have started banning or slowly phasing out this toxic propellant, looking at alternatives. So when we wanted to work in the space tech area, we realized we were already a little late into the game because satellites have been flying from 1950s, and then coming in 2015 and then finishing my product development by 2020. If I came up with the same product sets that the competitors are having, there is no edge or no reason why I have to make this company. So what we realized was the market was essentially shifting. So if you look at satellites till 2015, you would imagine a satellite the size of a mini conference room, and each satellite would weigh about 3 tons to 5 tons. They are all geostationary orbit satellites. If you remember your school, there used to be an orbit called geostationary orbit, which was where the satellite used to be stationary to a given point at any point of time. And this orbit was around 36,000 kilometers. So what is happening in the last 4-5 years is, or rather last 10 years, is satellite companies have started moving much closer to Earth to an orbit called LEO, low Earth orbit. And instead of 36,000 kilometers, we are coming all the way down to 600 to 1,000 kilometers. So essentially the same propulsion tech which was actually built 30-40 years back cannot be used right now, simply because the satellites are probably the size of the entire propulsion system. Satellites have become so small, electronics has shrunk down significantly, and you don't have so much power and so much volume available to have a propulsion system. That's where we saw, anyway, we are building a new product, let us build green propulsion. So when it comes to green propulsion, basically we took two approaches. One is a new technology called electric propulsion. Other is a technology called green chemical propulsion. So when it comes to electric, it's basically a new age technology where we will use the solar power available in the satellites as the primary source, and fuel is just a thing that we require to ionize the propellant. It's not something that we burn like you burn in a car. So we just ionize it, convert it into plasma, and then expel it out. And here we use green propellants. So that's one form of electric propulsion. But there are still some applications where the traditional way of burning fuels, just like a rocket, still has to work for satellite engines. These are applications where agility becomes very important. And say you're on a defense mission and you're currently looking at one geographical area and there is conflict somewhere else, and your satellite needs to immediately switch positions. There people will still go for chemical fuels, and that's where we actually invented a new chemical fuel which replaces the current toxic fuel, which is absolutely safe for the persons handling it. And it saves about a month of time in launch integration time, because you can actually fuel the satellite in the satellite factory, ship it, whereas the conventional fuel has to be loaded at the launch site, which means it takes additional month of loading time and all that. So here we developed a green fuel which is second of its kind in the entire world. First it was done by NASA and has now become the benchmark for green fuel. We are the second in the entire world, and so far happy to share that there are only 3 space missions which have flown with this, 3 space heritage missions. First was from NASA, second and third are from Bellatrix, and we are now trying to push that into the commercial market and try to work on that.
Adding to that, is there full awareness as of now, or there is still room for improvement?
I didn't hear you fully.
Is there full awareness as of now, talking about green propulsion, or is there still room for improvement? You're trying to create
it's still work in progress, because in a market where the cost of one satellite might go from 10 million to 200 million dollars, people take time before they change a proven part. So people are used to toxic fuels for the last 40 years, and it
ये
takes
भी
a
जी
lot of
लेंगे,
sorry.
ये भी जी लेंगे.
Yeah. So they kind of keep continuing. If it works, don't touch it, right? Why do you want to take the risk? Let somebody else take the risk first. So that way we are happy to share from a couple of government India agencies itself. We have got orders for our first systems and they're trying it out. And outside of India, there are again forward-looking space programs and companies which are valuing the environmental social guidance, ESG policies heavily. So they have already given us some orders, and a couple of them have already gone to space now. So we have just started, and there is definitely momentum picking up, and we are doing everything to incentivize the customer. And the best thing we are doing is we are saying our green propulsion is not just green, but it also gives you 15 to 20% higher performance, which only this fuel is capable of. So that's what we are actually packaging it in a better way, the way they want to hear it.
Congratulations to you.
Thank you.
Coming to you, Abhishek, what kind of state-led initiatives actually help in bridging the gap between startups and government? And I think that's one of the biggest role to play in order to drive the success of any startup. So what is that?
Sure. In deep tech, the problem is. Hi, can you hear me? So in deep tech, the problem is, technology-related risk. Technology failing, especially when you are trying to do something new for the first time. Today, states have become the first loss line, almost like insurance, right? By providing startups with incentives, cash and non-cash incentives, by providing tax breaks, by enabling these companies to sell their solutions to government agencies, non-government agencies, etc. By creating this set of incentives, it's reduced the risk for the entrepreneur significantly. And of course, there's a lot more to be done. But today, if you look at space tech as a particular sector, many state governments have set up space technology parks, which already has considerable amount of infrastructure required to do R&D, test your products and things like that, thereby reducing capital requirements to set up your own facilities. When Bellatrix started, over a decade ago, they had to set up everything on their own, all their labs, all their integration facilities. Today, I can build a very lean startup without having to invest in building capital intensive infrastructure. So that's just one example. Other than that, there are also several programs. If you look at the IDEX and Aditi kind of programs, if you're building in space tech, which has applications in defense, you can raise non-dilutive capital, which could be anywhere between 1 and 25 crores which is not insignificant for any early stage startups. So Government of India through the Startup India program and the SME registration scheme that it runs has already created a lot of it has helped break barriers for younger companies to be competitive in a highly difficult marketplace. And newer policies like the Startup India mission and state level policies have really enabled access to people, have access to infrastructure, access to technology. ISRO itself has a very active technology transfer program, which engages with private industry to move from R&D to industry. So all these schemes have really opened up opportunities for entrepreneurs. Either you can take very low risk, start something small, grow organically, or if you're adventurous, you can just go all out. And in both cases, you don't really need to have deep pockets to start. You just need to be brave. You just need to have the vision. You just need to know how to execute, and everything else kind of falls into place because of the right policy ecosystem that we operate in.
So adding to that, what are the top 2 gaps that you see while actually trying to bridge the gap?
Well, there are several gaps. We still don't have a perfect system, but I mean, let's not forget the new space, private space activities in India has only been around for 10, 12 years now, right? And in this short time, the progress we have made going from 2-3 companies to 300 companies, having a dedicated institution like InSpace, ISRO itself becoming open to working very closely with private space startups. I think there are a lot of things that are right. I still feel there is a skilling and education gap. Today, if somebody wants to get into space tech, except going to specialized institutions like IIST, which is an institution run by ISRO. If somebody else has to privately get in, they just have to do it on their own. They have to become multidisciplinary. They need to learn skills that they can kind of bring from other industries and experiences into any space tech arena. So skill and skill development, if that can be streamlined further, I think will also help industry become bigger, right? More skilled manpower means more people trying to do things and more startups eventually. So I think that's one very important thing that needs to be addressed and fixed. I think there are some government initiatives already working in that direction, but just not enough yet. And of course, we need more capital. Today, I can tell you from experience, when we saw the AI boom happen in 2023, the rest of the deep tech kind of took a back seat. Investments into deep tech, because AI was the fancy new thing that investors were chasing after. So I think we need to bring our focus back on non-AI deep tech opportunities and bring capital back to this industry. And I think if these two things are solved, majority of everything else can be solved pretty easily.
Thank you. Moving to you, Arjun, how do you see India's space tech startups, serving both defense needs and commercial angle without diluting focus?
Yeah, this is sort of a consistent theme/challenge that we see for most space tech companies. Everybody ideally wants to be dual purpose, right? And possibly wants to scale up on the commercial side as much as possible. I think we like to use, just to break it down into a simple framework, there is 2 variables on both sides. One is whether it is commercial use or is defense use. And then you say, are you domestic or are you global, right? And then you slice that, and then that's sort of your 4 matrix there, right? And we have to acknowledge that while there is immense potential for commercial use and some of it has already started, the early adoption and the urgency of demand really comes from the defense, right? And particularly commercial adoption domestically in India, which may be even slower or even lower. Therefore, when you're building a company out of India, a space tech company out of India, there will be some level, if not a heavy one, reliance on Indian defense as the first Indian defense customer, defense or government as a first or early adopter and customer. And the important thing to keep in mind is these agencies, Indian government or defense agencies, the desperation is there. Correct? It's almost all the time. Right? They're not waiting for things to mature necessarily. They are looking to be really, really relevant and competitive and okay because of the overall sensitive nature of geopolitics and more. Right? So I think the urgency of demand is a very big help for a startup, because startup time is of immense essence, and therefore who's going to try you first, who's going to give you your first order, who's going to give you a shot at experimenting with a new product, all of that. I think the defense becomes a good thing. There are the programs that were just recently mentioned, whether it's IDEX programs or the Aditi programs, etc., are great examples of that, right? And that really accelerates some of the early development. So we will have to rely on this for some time. Globally, then we can possibly go towards the commercial applications. There are many, many applications, but I think once you're space proven, have that pedigree, and then when you want to scale up, possibly then it's the right time to transition from, maybe heavily being on defense but then going defense plus commercial. That's sort of the lens we have typically seen. But early days, I'm still seeing that defense is definitely the key adopter.
Thank you. Yashash, so as space traffic intensifies, are you also working on autonomous collision avoidance? So if you can tell us a little more about it.
Well, that's a very interesting topic. We are definitely working on collision avoidance. On autonomy, we are actively building a AI algorithm which could actually be fitted with some sensors, which could actively sense any debris coming nearby in the 2 to 3 kilometer range, and if so, immediately it's a part of the propulsion package that we are offering. The AI algorithm automatically detects and triggers our propulsion system to outmaneuver such collisions. So this is something that again is a concept probably only a couple of academic papers are talking about, and nobody in the industry is doing it so far. So we are attempting that, and it's not just this. I think to be advanced, we also have a strong AI team which is trying to build in multiple building blocks into the space tech ecosystem, and this is one such example. But again, coming to debris avoidance, it is extremely critical for the industry, because today everything on Earth is kind of somehow intertwined and dependent on satellites. And if these debris start colliding with each other, it becomes there's a effect called Kessler effect or Kessler syndrome. Basically, one satellite collides with other, and somehow that breaks into 10 pieces. And these 10 pieces probably hit 5 more satellites, and that becomes 50 pieces. And each one of them is like a bullet going at around 8 kilometers per second in space, right? It can just shatter every satellite out there. And in no time, the entire satellite network is down. All our offices are down, servers are down. Probably entire life
Can you
that we
share
are
an
living today is going to
anecdote
go
to
down,
it?
right?
Like, can you share an anecdote to it? Something that you have worked upon?
What we have actually worked upon is there was actually one tech demo mission where we had space proven our propulsion system, and during the space propulsion test demo, we don't actually fire our propulsion system as the main system. It is a it's a test module, right? So what actually happened was, incidentally, the main satellite which was testing our system, it lost control. So it started rotating rapidly, which was not expected, and then it had to come under control. Incidentally, our system worked in that module, and our system acted as the primary system to just avoid that becoming a debris. And then we did not want to keep it there for a long period of time, because ours was a test mission. We didn't have a lot of fuel, so we actually gradually deorbited that and cleared that debris. So that way, that was one simple example. But I think on a day-to-day basis, that's this debris avoidance is one of the primary jobs that our engine is going to do. It's not autonomous at this point. We still track it from ground stations, and our customer basically actually sends commands to our system to activate it, avoid collisions. So that is something we do regularly, and it's like a critical part and parcel of the satellites going up today.
Thank you. Abhishek, Bangalore is called the tech hub. So how do you see regions, especially Bangalore, position itself as global space tech R&D hub?
Well, we've always been positioned as a global space tech R&D hub. ISRO is headquartered in Bangalore, and ISRO has been around for very, very long time. So this is something I used to tell a lot of people. Before we were producing motorbikes, we were building satellites in our country. We were building rockets. So, and it all happened here in Bangalore. Major space-related decisions have been taken here. We have a very active university ecosystem. We have great engineering schools. We have a thriving IT industry. So Bangalore is one of those hubs in the world which is very active, known for its innovativeness and things like that. So, but do we get all the publicity that we deserve? Probably not. I think the government can do a little bit in kind of highlighting all the achievements of Bangalore and Karnataka in everything that we've done and contributed to space tech, not only in India but globally. If you see the number of space startups in India, the maximum number of them are actually in Bangalore. So that should say something. Why are we here? Bangalore, nobody likes Bangalore traffic. Neither do, I'm from here. I don't like it. But why are we still here? Because this is where you get the talent. This is where you have peers that you can talk to, that you can work with, that you can partner with. This is where you have ISRO that you can go and get counsel and advice from. This is where we have an active venture capital ecosystem where we can raise capital from. So I think Bangalore is already a leader in space tech. It just needs a little bit more publicity. People need to recognize it and celebrate it.
Thank you. Moving to the last leg of the conversation, it's a common question to all three of you. What can India as a country learn from instances such as Operation Sindhu? Does that mean that we have a lot of innovation opportunities? So, Arjun, you can start.
No, absolutely. I think it is such critical moments really tell us what do we have in-house and where are we reliant on other providers for our own safety and our national security, right? And that is as paramount as it gets, right? And when that hits you, you start looking at your entire supply chain, you're looking at all your sources, all your partners, all your relationships, and you say, okay, we possibly have, we are only self-sufficient on 10%, 20%. So the opportunity is the other 80% or 90%, right? Just think about very basic system, GPS, right? We don't have a fully functional, self-controlled own GPS yet, right? Massive opportunity, right? Of course, surveillance, intelligence, Earth observation satellites, more and more, launches, propulsion systems for all the satellites, but also launch, right? Even now, most of our satellite companies in our ecosystem, some are launching with ISRO, but we don't have our own launch ecosystem. SpaceX launches most of our payload even today, right? And that dependence will hold us back someday, right? So having our own ecosystem and all of these things, right? These are all of national importance. And then we got to go back and start thinking about each component that needs to go into these systems, subsystems. Can we build the full systems? Can we indigenize the full supply chain? Do we have the materials? I think it's just a plethora of opportunity, and unique times like these really help us as an ecosystem, government, and all of us, capital providers, all of us together to wake up and say, hey, this is the opportunity, not just for 5 years, but 10, 15, 20, 25 years.
Thank you.
Well, I think Arjun was bang on. He kind of covered most of the things, and as he rightly said, GPS is one of the most critical but underrated parts in a war, right? So we had so much. I mean, the main thing about Operation Sindoor was precision in every strike. And how do you get precision? It's precise location. And unfortunately, India's GPS system is not operational, right? We do have our own, but today I think we have lost almost like more than 50% of the satellites for various reasons, and we are still dependent on Russia and US. GPS, of course, is US. Russia has its system, and we work with that. And tomorrow, for some reason, if US or Trump decides to just tweet that I'm denying GPS
I'm
to
sure
India,
he can
right?
once.
So if that simply happens, your missiles are going to just go all over the place, right? And then you are under embargo for firing at a hospital or something like that. So you have absolutely no control if you don't have your own GPS. So that was a major point. But over and above that, one critical data set that I think came out in the news media much later after Operation Sindoor was the use of satellite data by the Pakistani militants in terms of the actual incident which happened in Kashmir. So apparently, the entire map of that region and surrounding areas where the attack actually happened on Indians was already purchased by Pakistan from a major US satellite imagery company like 2 months before, and they had been using satellite data provider to keep looking at images of that various belts there, identifying which has to be the region where military cannot immediately come in and then counter them and they can have a safe escape path. All of that was studied through satellite data, and the kind of resolution that this US company had, even ISRO's cartosats are somewhat near, but we are not like at par with that kind of resolution. So supremacy in terms of the data quality and the accuracy and the time of delivery, right? Your data has to be more real time. If there is a military operation, something is happening, or tankers are moving, or missile launch base has just opened from a hideout, you cannot get that intelligence after 1 day, 2 days, or in sometimes all these data come after a week or something after processing. So how quickly can you process data becomes very critical. And if you're looking at the current Iran war, one of the major supremacy that Trump has tweeted about is actually the speed at which they are able to process data and the algorithms that they have deployed, which could do real-time data processing. Essentially, if they're sending out missiles and sending out their fighter jets and trying to see the damage, trying to see what the enemy is doing, your satellite ecosystem must have so much bandwidth to process and transmit all these data points real time and do the intelligence and decision making autonomously. It cannot wait for a data center and people working on shifts to keep giving you the information. The computer has to give you the final diagnosis and people have to just click on the command button, right? So that is something that US had and none of the other players this time had it. So all the countries are now trying to look at satellite supremacy and the amount of data processing and AI capabilities you can implement in a war situation. So this is something very new. And if you're looking at the Russia-Ukraine war, we never thought communication would be an issue. When Russia cut off the communication and all that, it was Starlink which actually gave the communication to Ukraine, and then Ukraine was able to continue and then beat Russia out again, right? So all these kind of are going around the technology piece. If you don't have the fundamentals right, the weapons would not really help you win the war.
Thank you. Quick comment from you, Abhishek.
Well, no further comments. I think my colleagues have already said a lot about space technology being used in defensive and offensive action. It's played an important role. I know many of my colleagues from the startup ecosystem were engaged, with the military leadership in supporting them through the process. I was told that over 10 satellites were used for continuous monitoring of locations across various targets in Pakistan. So space has done its part, and because there was an active startup ecosystem building solutions, having capabilities, we could do our little bit to support our government and our military leadership in executing this mission. So I'm proud of that. I think this partnership between the private space ecosystem and the government and the military will only continue to be stronger and onwards and upwards. So yeah, that's it.
Thank you so much. Thank you.